Good afternoon, everyone. Hope you all had a great lunch, and thank you for joining us today. Thanks to the DAX conference for having us. Today we're going to talk about tackling the challenges of combining disparate data sources in a traditional data science workflow using modular flow-based programming, or also just bad data and how to handle it. Today we'll be trying to show you how the data science industry is advancing and pivoting in terms of streamlining and improving the typical project workflow. So my name is Ruthe Huang. I am the Chief Data Scientist of Salynt. By trade, I am a data scientist, and I'm joined by one of my co-founders here.
My name is Dempsey. I'm the Chief Technology Officer of Salynt. I have a background in software engineering.
Cool. And during my day job, I am a government contractor, so today we'll be using one of our real client use cases to showcase an example of how to use bad data and the consequences of how we deal with it with our typical workflow now. So our client wanted to tackle this internal data problem. They wanted to help the relocating employees find federal jobs that are a good position and fit for both their skills and where they want to go. If anyone has browsed jobs on usajobs.gov, you can tell it is a pain in the butt to be filtering through dozens of these listings. The descriptions are also very vague, and often the locations are very varied because it's a bigger organization that's posting, so you don't know where the job listings actually are. And when someone's trying to relocate across the country or to another state, this problem is made even bigger because they have little knowledge of the local industry, any connections in that area, et cetera. And so the client wanted to create an interactive dashboard where employees can explore and also filter jobs by fit, and as well as geolocation. And by doing this, their intent is to retain more federal employees within the very broad-ranging federal sphere instead of losing them to private industry, as we're seeing more and more. In full transparency, this is just an analogy of our real client use case just because of confidentiality reasons, of course. So at its basis, with this tool, the user should be able to evaluate 3 different parameters. This is decided by the client. This was what we had originally scoped. So where the job is, what the job requires, and when or if the job will become available. Working with data owners for our databases that we have availability with, we found that the first 2 fields are contained within one data set that we're going to call dataset A, and the 3rd field is contained in dataset D. Now, obviously, to be able to use all 3 parameters in one tool, we're going to have to join together datasets A and D. The problem is here that A and D do not share any identifying keys. In our real-life scenario, this was actually quite a big issue. It took us several months to try to figure out how we could connect together these 2 datasets. And what we came up with was the following. So we found a dataset B that shared one primary key with, or not primary key, but shared a key with dataset A. Then a dataset C was also found that shared the primary keys of both datasets B and D. So using that, we could connect together all 4 datasets just to join datasets A and D. Now, however, the one big consequence of this is that as you're joining so many different times, we did lose more than half of our original data. And as you can imagine, another consequence of this is the code is absolutely gross. So not only does the server have to read in 4 different sources of data sets, they're all very, very different. And we had to optimize them and make a lot of manual tweaks so we could increase the amount of intersection between all of them just to get to the 48% that we still retained. So with the types of data, so most of these were tabular, but there was one data set that was just a collection of separate XML files. So we had to decipher that and then make them match up to the tabular data sets. There were a set of primary keys. One data set used a 10-digit version. Another data set used a 4-digit abbreviation, so we had to make those analogous. And then, of course, when you're dealing with geolocations, there was just a whole bunch of address data to clean up because the addresses are put into the database by humans, and humans are terrible at populating data. There were addresses, of course, missing cities, states, obviously a whole lot of misspellings. And sometimes we just got an address that said 5 Main Street. In what city, in what state, in what zip code, who knows? So that took a lot of fixing, and we used regex and just sort of some extrapolation, like guessing at cities. If there was nothing, but it said it was in California, let's just use Sacramento, who knows? And because of all of this, and this is just a nice little snippet illustration, of course, of a whole essay of messes, this server portion of the code runs quite slow because it has to not only read in and pre-process the data, but also make all of these changes just so we can have enough data to use for the dashboard. And we took a lot of time to do this. Some people might say, why is it worth it? Because the overall product, of course, is only useful to the customer if we maximize the amount of search options there are. So at the end of the day, we did deliver an MVP. This is a real screenshot of the tool we created. But sitting behind this somewhat nice looking UI is that mess of a server, right? So not only is it dealing with all 4 of those data sets and trying to process them and trying to keep them clean, but that it is reshaping the data in a way that is very, very specific to the problem that we had scoped out. Also, I forgot to mention this was done in R and is an R Shiny app if you can't tell. And that is relevant because R Shiny applications are not full-fledged software applications. So if you've ever tried to make one, you can tell that the UI capabilities and server capabilities are actually very, very limited. The server to this I call is very precarious because it's easy to break if you wanted to change this application to do anything else. So because of that, it does not adapt very well to big changes, which is in real life what was asked of us after we created this MVP. We were asked to add an additional feature to this tool. The client wanted to add a new data set to look at what billets traveled where, so that's an additional feature for users to be able to search. And unfortunately, we could not meet that ask in the timeline because it would have kind of just broke the server, so we would have had to rewrite the product just to accommodate that. And this is a problem that I think a lot of us have seen. We are calling it scope evolution, where the ask is an initial constrained, within an initial constraint, but then just naturally with additional analysis, with speculation, or even just the changing whim of a client, your scope gets broadened, it gets pivoted, or whatnot. And this isn't a problem, this is just a natural part of the dynamic data science workflow. But unfortunately, the traditional data science approach is not good at dealing with scope evolution because the way we conduct work now focuses on getting the analysis or the product out or done by a certain timeline, which is why for our use case, the server was precarious, as we call it, because it was very good at doing the one thing it was meant to do, but it didn't take into consideration future changes. So one downside of the way that traditional data science produces code is that from jump, the code is not written to be easily amenable, and it's often difficult to pass on to a different team. And because of this, the traditional data science approach actually makes bad data seem suckier than it really is because it's just such a pain to integrate into products that we think it's always the problem with the bad data is the problem with the bad data, but scope evolution is what truly multiplies it. So what we're proposing is that the solution that's needed for data science and overall for the workflow is it needs to integrate faster and also be more responsive to dynamic changes, which is what I'm going to have James here talk about.
All right. Thank you, Ruth. And thank you for giving us that look into the traditional data science workflow. It's very helpful to me as just a software engineer. I don't follow exactly the same process. And I guess from that perspective, it seems a little bit slow to me, or a little bit broken, in that so you said it took, how many months did it take?
It took a good 3 to 6 months.
All right, so 3 to 6 months of development time. And like you said, from your description, as you got more data sets, the scope began to evolve and things changed dynamically. To give another concise definition of scope evolution, when the goals or acceptance criteria change at all. So small details can change, and those details have to be communicated out to team members, and that creates opportunity for things to go awry or for things to become confused. and that creates the opportunity for messy code to be written. And so why is messy code such an issue? I mean, once it's packaged up behind your UI, does it really matter? And yes, it does, because you need to be able to bring on new team members to support your project. You need to be able to reuse your project in other use cases and other situations. And it would be much better if you didn't have to completely tear down the project and start it from scratch in order to do that. It's also difficult to explain code in general. Usually when I see it, it's just a wall of text like Ruth had up there before, and even in other presentations I've seen, it's usually just a screenshot of that text. And there's very little context communicated in that. I might as well show you today's newspaper and ask you to tell me something about it. It's just not there. So what is the problem here, and how do we fix it? Because scope evolution rather, is going to happen no matter what. You can't avoid it. It's not the problem that we can solve. It's driven by internal forces, like Ruth said, where team members want to, they have an interest, an active curiosity in the data that they're discovering, and so they want to explore more into it. And so maybe they want to change the direction of a project, or maybe your leadership or management wants to go in a different direction given the current progress that you've made. There are different things that can change that direction. And so that's not a situation that's ever going to change. You can't stop that and say, well, we're only going to work on projects that never change. And so the solution to that problem this problem is really iteration speed. We wouldn't have an issue with scope evolution if the iteration could keep up with that scope, right? If you had a project and it only took a day to complete, then tomorrow you can have a new thing and iterate on that. So if we need to be able to iterate faster, why can't we? And that goes back to the messy code that you had mentioned. And in a nutshell, I'm going to blame messy code, but to develop clean code, there are 3 different levers that are needed. There's time to do it, there's the skill to actually know what programming is, and then there's the context to know what goals you're trying to accomplish. And the evolution of scope applies pressure to all 3 of those levers. It makes it harder across each one of those fronts to accomplish a task. And so there has to be some way to alleviate that pressure that's been placed in order to allow iteration to proceed faster. And the solution for that we've come up with is modular flow-based programming, or what is typically referred to as no-code or low-code, but you can really think of it almost as just a flow chart. If you can describe the process, the project, the task, whatever your objective is, as a collection of steps with data passing between those steps, then that is what I am talking about here by flow-based programming. The low-code, no-code solutions that currently exist, there are literally hundreds of them right now, but they tend to be drag-and-drop icon-based tools that you can connect together to form networks and network graphs of different processes. And this, to me, is an extremely convenient way to communicate things and to implement applications because it visually documents the code for you. It's an intrinsic documentation. The structure of these icons and how they're arranged themselves literally tells you what is happening. So modular flow-based programming, or a no-code, low-code approach, I would describe here as a specifically modular thing, what do I mean by modular? I mean grouped into units, into icons, into blocks, into some sort of discrete unit that can be moved around and interacted with, so that it isn't a wall of text with no boundaries. Its purpose is to provide that sort of normalized interaction, that whatever you interact with will always have the same way of connecting these things together. Doing that allows you to actually reuse code. I don't know who here might be a software engineer, might have software background, if anyone, but object-oriented programming, which is a very popular paradigm, or at least it used to be more so a few years ago, it never delivered on its promises. To me, it's always this great idea of we can reuse your code if you make these reusable modules, but you could never pop them out. You could never isolate those things and make them truly reusable because they were never a nice little icon that could be moved out of it. It was just trying to pull a paragraph out of a book. The context cannot be taken with it. And so when you have this modular approach, it really does allow this independent isolation of components. And that allows you to create applications as collections of these components, each of which is totally unaware of their actual use in the overall application. Basically just reusing the same pieces over and over again. And this is a form factor that makes it easy without having to actually create a special signature or a thing to pass around with it. That allows you to do this, to create applications and to perform data science things in a scalable and maintainable way. When I first started as a consultant a few years ago doing data science work, it startled me when they kept wanting me to rewrite these same exact algorithms over and over again. I'm like, how many times do I need to write k-means? How many times am I going to have to do PCA? I mean, it's all the same, right? So why can't we just pull that out and reuse that? And the answer is because it's been wrapped up in context. And you need a way to actually pull that out. And once you've done that, then it becomes scalable because you can describe your applications as just a collection of tools from your toolbox. And if you can do that, then you can allow your team members to each work on an independent tool. They can add their own, they can design their own things, they can work collaboratively, but still independently. They can still communicate what they're doing and provide a normalized interface to use everyone else's work, but still be able to scope what they want exactly to the thing that they're working on. And by doing that, you allow your teams to create these much more complicated projects, these bigger applications that can combine more data and process it and do more interesting things across a wider group of people without having to have, an encyclopedia of Confluence pages being written for documentation so that nobody can, update it and things like that. So there are a lot of companies that do this. Some of the big ones, AI Squared, Alteryx, Datadog, Salynt, obviously. Yeah. I didn't get any pictures of theirs because of copyright concerns on my part, and I didn't want to be advertising, but they are all great products, and I'm more interested in communicating to you all the value of this space. I have some pictures of our product, which we are currently doing a pilot program for, but the idea is that these components can be independently specified and then connected. So the piece that you see up here, the green ones actually correspond to legit source code. There's actual code there. The blue ones are organizational groups of other ones as well. These can be iteratively or recursively defined lower and lower, like little nesting dolls. So whatever recognition happens to be in this case, it might involve a bunch of different processes, but I can actually flesh that out in the data science context. I can use my education and experience to say, I do know how this can work. I know the procedures. Maybe I don't know how to build the structural scaffolding code to build this whole application, but you don't need to do that with this. The whole concept of flow-based programming sort of allows you to ignore that scaffolding code. Maybe that's a better way to put it. If I were going to design a house, if you were going to design a house, you wouldn't really care maybe where the sink goes or where the windows, you would care where the sink goes, where the windows go, where the doors are, but you don't care where the vent stack goes for the pipes, you don't care where the electrical lines are going, you don't care where the plumbing is. That's all stuff that needs to be there, yeah, but it only needs to be there to make it work. You don't care about it. No one's invested in exactly the layout. So if you can get rid of that, if you can abstract it away, then it makes it much easier to develop and reduce that iteration time. So some of the advantages that you can end up with from this, that standardized data processing model makes it extremely easy to track where your data is in an application and what's happened to it. To go back to this previous page, if the first one takes or outputs a blurred image and the second process does some form of recognition on it and outputs an image of its own, like you can see exactly where the image data is. If the image isn't correct, if it's a different picture, you can track exactly where that came from. Did it happen in there, or there? Because there's 3 images that came out. That's where each are. Look at each one of them. See where it went wrong. You can look at it in this standardized processing way where you can see everything happening. It allows you to add any data that you want by just adding another icon, essentially, by clicking and connecting it in. There shouldn't be this barrier of entry to adding your data into your application or to trying to spend months trying to collect these things on the same keys. It should be as simple as connecting them in and just going. And therefore, it also lets you scale that quality assurance aspect as well, because if you can track your data, if you can perform auditing and QA on it and say, like, yeah, these are the correct steps, this is what it should be at each step, then you can confirm, yes, this is reliably what we've done. And that's very important for any data science application. I think that's all I've got. So if anybody has any questions.
Thank you so much for listening.
Yes, thank you.
Do we have any comments, questions?
talk a little bit about scope morphology and scope creep. I would like to ask about your usage of both version control and agile methodologies.
Version control, you mean in terms of our own code base, or how do we facilitate it for users?
In terms of how does the user maintain versions between different, as they continue to work on the software, how do they differentiate them?
It's backed up with Git on the back end. Each change creates a separate file, which is periodically, they can either deliberately save it directly or create a new version, or it will just periodically be updated with new versions regardless. But it's all backed up in GitHub.
Thank you.
No problem.
So I want to ask, how is the no-code and low-code different? The concept of modularity different from just writing a bunch of static methods and using functions?
I guess the way that I'm using the word modularity is not the same as the way that software engineers might use the word modularity. I'm using it to very much say, like, to encapsulate it, which is another word I should be careful with, but to encapsulate it into like a specific thing is what I mean. I recognize that it's not the software engineer use of that word, which I think might be part of the question. Does that answer at all?
Yeah.
Ish, yeah.
In like from the data science perspective, I think it's kind of like when we write a script and let's say you keep referring to an object M, and M is scattered on line 3, on 100, on 322, instead of just being contained sort of in, and perhaps if you make a change, you have to go through the whole document and change exactly where it references M. And I think my data science interpretation of the way that is, the module will contain all that more in one place. So when you make a change, it is all targeted within that one module. And you don't have to, again, be control F'ing all over the place or read through all of it. So,
Okay, cool. Thank you.
Yeah, sorry.
So hi. So I just wanted to ask how the no-code or low-code deals with the null values, because as I heard, there are a lot of null values in the data set, and it's really complex to deal with the null values.
It would depend on your low-code platform. Some of them would provide specific tools that would deal with it in different ways, and they would have, I guess, predefined ways of saying, it would drop all nans or something like that. Maybe it has a few different choices. For our platform, we strongly believe that we will never know all of the ways that you might need to use the tools that you might need, so you can add and modify the tools at your own, at your leisure. So if you design a tool to be more generic, then we can support that, and you can always use it over and over again in your own software. Does that answer your question?
Yes. Thank you so much.
thank you.
No problem. Thank you.
Hey there. Thank you for the talk. Excellent presentation. How have you found the tool to assist with collaboration? Because my experience has been when I need to work with non-technical users and explain to them how a model might work, you can't bring up the code because their eyes just cross and they start to pass out from boredom, and it does not go well.
Correct.
And I found that if you have sort of a palette and canvas approach, which looks like sort of what this is, that it assisted with collaboration. Have you found that to be the case as well?
Yes. What I found was every time I asked someone, how do you want to make this thing? Or what is it doing? What do you want? They would take a marker, they would go to a board, and they would start drawing circles, and they would start making arrows between them. And I felt that that was what we should be doing, and that is absolutely why, because it immediately facilitates that communication. It does make it so much easier to be able to present code like that.
No, continue, finish.
I was going to say, a wall of text is never going to help anyone. It's like one of the presentations where, someone shows you, here's the code, scroll, 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 and then you see this part, scroll, 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 and you have no idea what's happening.
I find that only effective if you really want to show your bosses how much work you've done. Like, look, I have written things. But also from experience of the application side, yes, absolutely, the visual way to present it is better. Because again, you can draw it on the board, but then they really want to know the technical details. But they want somewhere in between a circle on a board and the actual code. So something like this, where if this was your actual workspace and you are working on this, they can see there is the technicality of it. But then, for example, we're always asked if well, what method are you using on the data? And then you can just say, exactly right here, we are using blur image. So, or like, oh, did you strip out the PII? There could be a module. Yes, see right here, you strip out the PI. So we find the visual way very intuitive for non-technical stakeholders, for sure.
Something that may or may not be helpful in your endeavors is I actually first learned how to do data science in a no-code tool back shortly after the earth cooled. But it was from a company called Unica Technologies, and they came up with a product called Affinium Model, which was actually designed for end users who were marketers to be able to build their own models. And this started back in 1994, and we were actually able to get marketers up to speed building their own models in about a day and a half. You can still find that old documentation online. It isn't the world's prettiest interface in terms of the visuals, but in terms of the structure and sort of the two-level approach with here's what an end user might want to be able to put together in terms of pieces, and then the next level down with code, for whatever it's worth, it's still online.
Well,
Thank
thank you for the
Appreciate
suggestion. Appreciate it.
Anyone else have any questions or comments or criticisms? Switch it up.
We still awake after lunch?
How do you feel about AI text code? Do you think that might be a disruptor in this product?
Not to this product, but to the industry in general,
Well,
yes.
obviously, but if you're talking about modular, you'd be able to say, this is what I want this module to do.
Yes. Yes. I do see that as a major thing in the future. I look at software development and data science right now as being extremely unscalable. You just can't scale that development up. It doesn't work like that. And so, yeah, in the future, there's going to be a need for that sort of thing. It's going to fill, imagine it's the future, right? You have all these flying cars and stuff going around. Who programmed them? Because we don't have enough engineers to program them. You're not going to make enough engineers in the timeline that you're picturing that future. So I know that that use case is absolutely going to be there, and I completely agree. It's going to be a disruptor for a lot of things. Yes?
Is ChatGPT in this?
Can support ChatGPT, yes. Ours is extremely easy to add stuff to. Yeah, we do ChatGPT. We do machine learning applications, data science, AI, quantum. We do quantum too. Why not? We actually do. But, you know.
Could you describe how you use quantum? Like, what does that mean? I know it's like 10 years from now, but people are heading towards it.
Yeah, I think there's a huge opportunity for us to be we can build quantum circuits in this application, and then those circuits can be sent off to quantum computing supercomputers to actually implement the circuits and then feed the results back. So we're able to integrate machine learning and data science with quantum computing and sort of cross-pollinate those things. I think that there's a lot of interesting work that can happen going forward with that, and like you said, as quantum becomes more and more prevalent, then it will be much more, it'll just increase being interesting.
Cool. Well, thank you all for your attention, your time, and your questions. Really appreciate it.